is the recording. I guess you all received the email from me, right? About the link.
Yeah.
I think so. I just kind of give you a reminder so everybody I send a link. All right, I think so. The test number 1 is already graded, so you can check your grade on D2L. Okay. And then today we will focus on lesson 5, which is decimals. So we will do the introduction to decimals. And the word decimal comes from the Latin decim, meaning 10. And if we have 23.5, the dot in 23.5 is a decimal point. And next, we're going to talk about the decimal places. So for instance, like this, we have 12, 0.618. What does this mean? This means, so I'm gonna do a table like this. So I have a tens and ones and decimal point and tenth and hundreds and thousands. So 1, that means 1/10. 2, that means 2 ones. And we have decimal point there. 6 means 6/10. 1, that means 100. And 8, that means 8,000. So we give the meaning for each digit, all right? So therefore, that's the 12.61a. That means we have 1/10, 2 ones, and 6/10, or 100s, and then 8,000s. So that's the meaning for this, okay? And then next, we're gonna talk about the decimal fractional meaning and common fractional notation. So fractional meaning and then common notation for this. So here's a decimal and then fractional meaning. And then common fraction notation. So for instance, 5.3. All right. And what does the meaning for this? So the meaning for this back to the student's previous knowledge, which is a fraction. So that's the 5 and 3/10. So that's a fractional meaning. And common fraction notation. That means we have 5 and 3/10. How about 0.02? What's the fractional meaning? The fractional meaning, that means we have a 0 for the ones. And that means we have a 0 for the 10. That means 2. That means we have a 2 over 100. So 200. Well, I think you guys log in okay, right? Why somebody cannot log in? I think that this one is okay. Right. Just a second, okay? How come people cannot log in? Okay, I think so. Yeah. So you guys log in okay, right? So you just click the login, is that right?
Yes.
Yeah.
But how come some people cannot log in?
I had to go through my calendar to get in for this one.
I
Oh,
know
you
I
have to go to
usually do
calendar,
it through
right?
Teams because when I try and join through my email, it tries to go to my personal account instead of my school account.
Yeah, I think I send the email, the link to everybody. You're supposed to click the link, supposed to can log in, right? Oh. So you go to the school account, is that right?
Yeah.
Okay. You go to school account, then you just go to Teams and just log in, right?
I go through either my email or the calendar on Teams.
That's what I do as well.
Are you guys still there?
Yes.
I look in from the school email, and then I only see you 6 of you, and then out of 15, I don't know where they are. Yeah, I think I log in from the school email. Yeah, we are here. Okay, okay. Yeah, one more people join. I don't know what's going on with the team for today. All right. So more people join.
Hi, Professor. I don't know. Yeah, I don't know what was going on. Myself and like 15 other students were sitting in another meeting. It was really weird. I'm not sure.
Yeah, I'm not sure because we have I set up this and then log in my email and log in on the Teams. I cannot see you guys. I don't know
Yeah,
why.
that's so weird. We use the link in the email, but I don't know what happened.
I'm sorry. I just Teams. I
Oh, no, it's
mean,
okay.
yeah, I'm just waiting here. Nobody show up. Yeah. So only 6 people show up. Now we have more people join. Did you join by the email I sent to you?
So I first joined with the email that you sent last week. Whatever email sent with the stuff for
Week
today.
7. Week
Yeah.
7. Yes.
Yes. So I
Yes.
used that link, and then I was trying to mess around with it and it wasn't working. So I left the meeting and then went to my calendar on the left-hand side in Teams and then just clicked on that join link and I used that and that's how I got in here.
Because I was trying to remind everybody. That's why I provide a link every time. Make sure everybody can join. So I don't know what's going on for today because I have a technician cam help me with this and then set it up and then I think I don't know. Maybe I
Yeah,
will
I'm gonna
ask them again.
I'm gonna send an email to one of the girls that was in the meeting that I was just in and tell them how I did it
Yeah.
real quick.
Yeah. Just tell them there. And I think so. If you join week number 7, I provide a link, right? And you just, or maybe the way you did, okay?
Yep, you did provide a link.
The way you did, okay? Sorry about that. I don't know the technology of Teams.
No, it's okay. I'm gonna send an email.
Thank you very much. All right, where we are. Let's continue. Maybe, if someone cannot join today, they can watch the video, okay? So everybody hear me okay? The sound's okay?
Yes. Yes.
Okay. And I'm gonna continue to do this, okay? Yes. Yeah, I think so that I send the link to everybody is supposed to join like this. But anyway, so we talk about the fractional meaning and we talk about the fraction common fraction notation. So we have a 0.02. Yeah. That means fraction meaning we have a 0 for the units and 0 tens. And then 2, that means 200th, okay? And what's the common fraction notation? And we will do this common fraction notation to all 100. That is a common notation, okay? All right. Somebody cannot get in. So you guys log in through the Outlook calendar, is that right?
When I log in, I go onto my Teams home and it shows if the call is open or not yet. And I can join from there, but I can also join from the calendar.
Mm-hmm. You can join the calendar. That's what I did. I joined from the calendar. All right. So let's move on to next one. Convert each of the following decimals. Okay. Right, are you guys ready to learn? Yeah, technology. Yeah, I hope. All right, very good. Yeah, I feel a little bit frustrated for today because many people cannot join with the. I don't know. Maybe the teams. We have to reset. All right. So now we're gonna convert each of the following decimal. Okay, convert each of the following decimal. First of all, 500. All right. 500, and then we have a two method we can do this. 5 out of 100. All right, we have two methods we can do this. Okay, the method one is this. You take a 56 there, and then since this is a divided by 100, divided by 100, so we will count the decimal point. We count the decimal point. All right, decimal point right there. So we count the decimal point to the left or to the right. To the left or to the right.
The right.
To the right.
No, sorry, no,
No.
left. Go back to left.
To the right, look, we'll get more,
To the left,
more, the more, right? So now it's supposed to be to the left, right? Now to the left for how many?
yes. 2.
So this is 2, right? That's a 1, and that's a 2. Okay, what does this mean for why we have to move 2? Because when we move 1, that means divided by a 10. When we move 2, when we move the decimal point from 56 to, for 2, that means we divided by 100. So that's why move to the left, right? Okay, more people join. That's great. That's great. Thank you. All right. So does it make sense to you? Why we have to move the decimal point for 2? Because we divided by 100 there. If we move to the right, then therefore we times 100. Is that right? Make it as a bigger. Yeah. So that's the method one we can do for 56 divided by 100. And what is the method two we can do this? The method two, what we can do this is, but this problem is we only divided by 100. So luckily, we can do this way, okay? And now what about method two for doing this? We can use a long division to help us for this. 56 divided by 100.
56 divided by 100.
Okay. Did Nikki get on here? Everybody was like stuck and running around trying to figure things out. Okay, good.
Yeah. All right. So 56 divided by 100. Okay. So we can use a long division for this. If the button right here is not a 10 or 100 or 1,000 or 10,000, then we have to use the method two. We cannot just count the decimal point, right? So we can use the long division method, right, to do it in this. So we can use a long division for doing this, and then we have a decimal point divided by 56 divided by 100, and then move on next place value, that's a 5, right? So we have 500. Subtract this, 60, and move to next place value, which is a 600, and we have a 0.56. Okay. So I do one problem and you will do one problem, okay? Let's try this one. I'll do one problem, you do one problem, okay? How about this one? Convert this one into a decimal. Go ahead. You can do either way. You can do method 1, you can do method 2, okay? Okay, are we done? Are we done for this? All right, so how about we do method 1? So if I like to convert this to decimal, so I have a 205, writing 205, okay? Right, method 1 is like this. So decimal point right there. So how many zero there? That's 1, 2, 3, 4, right? And that means we're gonna divide it by how many? That means we're gonna divide it by 10,000. So let's move on to decimal point. To the left or to the right?
Left.
Left. Yes, thank you very much. The left, that's the divided by 10 right there. Divided by 100 there. Divided by 1,000 there. Divided by 10,000 there. So therefore,
10025.
0.0, yeah, point, yes, right here, yes. So therefore, 1, 2, 3, 4, yes, and 0.00205. All right. Now, what about next problem? We're gonna do the terminating decimal. Right. Now here is a definition for decimals. And terminating decimals that can be written with only filling number of places to the left of the decimal point. All right. So here is example. If I have a 1/2, convert to 0.5. The decimal can return a finite number of places and to the right of the decimal point, okay? So if I have 1/3, and which is, if I take a 1 divided by 3, I will get a 0.3 repeating, right? So this is a terminating decimal, yes or no? 1/2, yes or no? Yes.
Yes.
Yep.
How about 1/3? Is a 1/3 terminating decimal, yes or no?
No.
Because we continue to do it, right? 333, we don't know. Okay. What about 1/4? With 1/4, we convert this as a 0.25. Terminating decimal, yes or no? Yes,
Yes. Mhm.
yes.
I'm sorry,
How
the
about
slides,
one?
I'm so sorry, Professor, you didn't upload the slides yet for us to print out?
Say it again.
The lesson slides, they're not available yet for us?
The slide,
Yeah,
can anybody see the slide, yes or no?
I see it on the screen now, but I mean on the D2L, it's not up there yet?
Oh, okay. So D2L is not, yeah. D2L I will upload later, okay?
Okay, all right, that's fine, thank you.
Yeah, D2L I will upload later, okay? After I finish teaching, every time I will upload to D2L, okay?
Okay, sorry to bother you.
All right. So 1/4 is a 0.25 if I convert to decimal, and then there's a convert to decimal, and therefore this is a terminating decimal, yes or no? Yes.
Yes.
Because the last digit is a 5, right? What about, so this is a yes. How about 1/5? 1/5 I convert this is a 0.2, is that right?
Yes,
So terminating decimal, yes or no?
yes.
All right, yes. Now what about 1/6? If I have a 1/6, then I would have a convert this to a decimal is a 0.16 is repeating.
Mhm.
So this is a terminating decimal, yes or no?
No,
No, very good. How about 1/7? 1/7, I converting this is a 0.142 5 7, and then continue 1 4 2 8 5 7 1 4 2 8 5 7. Yes or no?
no.
No. Okay. Now here is another one. 1/8. If I convert this one is 1.25. So this is a terminating decimal. Yes or no?
Yes,
Yes. Very good. What about 1/9? If a 1/9
no.
change this is 1/1. So this is a no.
Mhm.
Okay. What about 110.1? Yes or no?
Yes,
Yes. All right. So now let's observe. Okay. This is a yes.
Mhm.
This is a yes. This is a no. And then this is a yes. And this is a yes. This is a yes. Okay.
Mhm.
What did you observe? What did you find? What's the pattern did you find? Did you
Mhm.
find the pattern is something like a theorem here? If it divided by 2 and 5, and no prime number, and that will be terminating decimal.
Oh, cool.
If we divide it by something with a 3, it's not in this, is a 205. So therefore, it's a, kind of a repeating, right? If it also for 7, it's not on a 205. So repeating, right? Or 2, what about 6? 6 actually is 2 and 3, right?
Mhm.
So you have a 2, yes, but you have a 3. So therefore, So
No.
that's why it comes with repeating and repeating. Does that make sense? So
Yeah,
here is a theorem. A rational number a over b, okay, in the simplest form can be written as a terminating decimal if or only if the prime factorization of the denominator contain no prime other than 2 or 5. So look, if we have 2 or 5, purely if this is a 10, is a have of 2 and 5. Yes, of course, this is a terminating decimal, right?
Mhm.
So here is example. We can examine for this, okay? Without doing this, because this is the theorem is helping us to determine, okay? So 7a terminating decimal, yes or no?
Yes, because eight
Yeah.
is divisible by two.
Yeah, a actually is a 2 and 4, is that right?
Yeah.
And then 2 and 4 is a 2 and 2. Yeah, of course, yeah. So you take a 7, all right? You take a 7 and divide it by a, and you would get what number? 7 divided by
0.875.
a. Oh, yes. So we can have a 0.875. Oh, terminating decimal.
Mhm.
It's not repeating, right?
Mhm.
All right. Can you do the second one. Take a minute, do this one. 21 over 28.
It's gonna be yes,
give you a
because it's divisible. Right.
I want to give you a minute to do this, okay?
Okay.
I want to give you a minute to do this. And you want to tell me this is a terminating decimal or non-terminating decimal.
Mhm.
Okay, what's your answer?
Yes.
It's a terminating. Yeah, it's a terminating decimal. But first of all, it has to be what? Simplest form. We have to base on simplest form to exam, okay?
Mhm.
Is this a simplest form, yes or no?
No.
No. So we have to reduce the fraction by what? By 7?
7.
Divided by 7, we got 3.
Fourth.
Divided by 7, we got a 4. Is that right?
Yes.
So therefore, yes, 2 and 2. Yes. So this, of course, is a terminating decimal. Does
Mhm.
that make sense to you?
Yes.
All right. How about the next one? Can you do the next problem for this?
Mhm.
11 over 250.
It's
Actually, actually, we can simply determine by the denominator, right?
yeah. It is.
It is, right?
Yeah, because 5 goes into it. Mhm.
Based on this rule, other than 5 or 2, if we have 2 and 5, nothing else. If we have 3 or have 7, or it should be no. Okay. So first of all, can you tell me this is the simplest form, yes or no?
Yes.
Yes. So if this is simplest form, then we can base on this to determine, okay? 250, which is 5 and then 50.
Mhm.
I take a 5 prime number, right?
Mhm.
So 50. Then 50 prime factorization means 5 and 10. Is that right?
Yes.
And then 5 and 2. Yeah. Oh, we have, look. Do we have anything else? We have only 5 and 5 and 5 or 2, right?
Mhm.
So therefore, yes, this must be a terminating decimal. So now I'm going to use in my calculator to exam 11 divided by 250. Oh, so therefore I got the 0.044. Yeah, terminating decimal. Double check. Does that make sense to you? How to determine terminating decimal?
Yeah.
All right.
Will we get the same answer if we were to do like 25 and 10 instead of 5 and 50?
Yeah, 25 and 10. Yes. But look here, we have space on the theorem. If we find either 2 or 5, should be okay. But if we have more, if we have a 3, we have a 6, or we have a 9, then it's not the terminating decimal. Does that make sense to you guys?
Yes.
Yes.
All right. Then next, we're gonna talk about rounding decimal. Okay, rounding decimal. The round 3.6147. So to the nearest tens. So to the nearest tens. So here we have ones, we have tens. So nearest tens right here. Is that right? So I mark the nearest 10, right?
Mhm.
And then to the nearest 10, that means we're gonna use this number to exam. More than 5 or less than 5?
Less.
One is more than 5, so less than 5. Okay, so answer 3.6. Rounding. Does that make sense to you?
Yes.
Next one. To the nearest hundreds. To the nearest hundred. So we have a nearest 100, so I'll mark this one. So we want to use the next number to exam. Next number would be, next digit would be 5. 5 is less than or greater than 5.
Equal
Or
to
even-
greater than.
Greater than 5. So we're going to greater than 5. We round it up and then move it is a 2. So the answer is a 0.02. Are you with me?
Yes.
Yes.
Can you do the next problem?
Mhm.
Round 7.456 to the nearest 100th. All right. So therefore, hundreds. So therefore, I'm gonna take a 5 and mark this one.
Mhm.
All right. And I'm gonna take this one because a 6 is greater than 5. So the
Mhm.
answer is a 7.46. Very good. Next one. Round 7.456 to the nearest 10th. To the nearest 10th. So nearest 10th right here, that's the 10th, right? So we're gonna use the 5 to exam. So therefore, the answer is a 7.46 again, right? What about nearest units? The units right here. So we're gonna use this number to exam. 4. 4 is greater than 5 or less than 5?
I'm sorry, wait, for the problem before that, wasn't it 7, shouldn't it be 7.5
so
because
far-
the nearest 10?
Yeah, we're looking for, sorry.
You're good.
That's right. So the hundreds, right? Yeah, looking is no, the nearest well, this one, then this number, the nearest 10th, right? The nearest 10th. So therefore, you're gonna use the nearest 10th right here,
Mhm.
right? So therefore, we're gonna use this number to exam. Yeah, that's right. Yeah, so 7.5. Is that right?
Mhm. Yes.
Yeah. The next one with units right here. Units, right?
Mhm.
So therefore, the answer is 7. Is that right?
Mhm.
Okay. All right. So taking care of rounding decimals. Next, we're gonna do 18 as subtracting decimal. Okay, 18 as subtracting decimal. Again, there we have different methods for the slow learner or everybody, general learner, and then also we have method for quick learner. Okay.
Mhm.
Right. So let's say we wanna do this problem. 23.47 plus 7.81. Okay. So for the method one is good for everybody. Okay.
Mhm.
So you want to create the table like this. You have a tens, ones, and decimal point right there, and tenth. Next place value is hundreds. Also clearly place value for each one, right? So therefore, 23, that means 2 tenths. 3, that means 3 ones. And then decimal point, and 4 tenths, and then 700. Is that right? And then next, 7.81. I mean, we have the 7 ones, and decimal point right here, 8 tenths, and 1 hundredths. So we want to add together.
Mhm.
Now we add together, yes, this is a good for everybody, right? So 7 plus 1, which is 8. 8 plus 4, which is 12. So put a 2, remember 1 there. So 7 plus 3 plus 1, which is 11, right? Now 11, we have to carry 1 there. So 2 plus 1, 3, right? So decimal point, we have to line it up, yes or no?
Yes.
So yes. So we have to do the lining of the decimal point. So 31.28. That is the good for the general learner or everybody, okay? And let me show you another one for quicker learner. All right. Let me show you another one for quicker learner, which is method 2. Now, quicker learner, they can do mentally, right? They are smart, they can do mentally. They can, without making any table like this. All right. So again, remember last time we talked about compose and decompose method. Remember that? And we can also use this method for decompose and compose. Okay. So and that's kind of things for we can helping children. They have smarter children. They can do the mentally. Okay. So we can decompose whole number and decimal. So we have 23 and 4.47. And then another one is 7 is a whole number. And then the decimal goes to decimal. Fraction, decimal, and then go to decimal. And then we kind of get, and then whole number and a whole number. So we can do whole number add together. So whole number add together, all right, which is 30. Then we can take care of the decimal, all right. So therefore, this is remember, this is only good for quick learner. They can calculate this in their head, okay? So they can write the answer right away here. So therefore 1.28, and then all together it's a 31.28, right? Now, eventually, this part is all in their head. They can count with the mentally. 23 plus 7, 30. 4,700 plus 8,100, how many? 1.28. And combine together, 31.28. Is that make sense to you? Quick learner, their thinking is different from the general learner thinking. Right? So that is, yeah, that's because they're using the methods to kind of decompose and compose, right? Yeah. And then using this mentally. Eventually, that's completely gone. It is all in their mind, right? If you see the quick learner, they were doing this, but actually their mind is right here. They're doing very quickly, all right? Sometimes you can see the quick learner, how they process. This is how they process, okay? All right. How about, I'm gonna give you a problem, all right? And you wanna try it, okay? See if you can do different method, okay? How about you do the next problem? 250.28 plus 3.24.
You wanted in method 2 for us to do it in?
Yeah, I think why can you try method 2? Because everybody knows the method 1, is that right?
Right.
Yeah, I want you to try method 2 because just in case in your classroom you have smart children, right? And then you have a smart children, they can say, hey, I'm gonna show you this. should do this one, okay? Using compose, decompose, and compose, okay? And maybe you can try yourself, okay? Can do a mental computation. See if you can just arrive the answer without doing any writing.
Yeah. That's easier and faster than the actual decomposing for me. That hurts my heart,
yeah.
the decomposing.
See, that's why we have to learn different kind of
Different-
methods, because some of
yeah.
method is
Mhm.
better than we have in the past, right?
Yes, of course, yeah.
And actually, this method is in the German classroom. They kind of training children with a mental computation.
Mhm.
All right, are we done?
Yes.
All right, very good. So I'm gonna decompose this at 250 and 0.28. And here's a 3 and 0.24, right? So this is a 250. This is 0.52. And then add together, it's a 250.
Three.
253.
Mhm.
And then 0.52. Okay,
Mhm.
right? Much quicker, right?
Yeah, much
Yeah.
quicker.
All right. Yeah. Now, what about can we do this way for the subtraction? Yes. Again, subtraction we can have a journal learner, and we can also what's the method one? The method one for journal learner. So 2.53 minus 1.3. So therefore, for the everybody and journal learner like this, you have a ones, decimal point, 1/10, 100s, right? And also this method is good for journal learner and also good for special ed, right? Special ed.
Mhm.
The special ed they need the method, more clear. Right. So 2.53 and then subtract 1.3. So therefore, subtract this. And then we got 3 there, we got 2 there. Decimal point, line up, yes or no?
Yes.
Yes. All the addition and subtraction, we have to line in up the decimal point. Okay.
Mm.
So therefore, that's 1.28. Is that right?
Yes.
Now, what about, can we do the method 2?
Mhm.
Is the method 2 working for this? Yes. Let's try it. So we decompose this as a 5 and then 53. Is that right? 5,300. And then we could decompose this as 1 and then 3/10. And now we want to do subtraction here. Subtract this, we got 1.
Mhm.
Subtract this, we got 0.23. So now once we done all the subtraction, what is in total? Is 1.23.
Mhm.
Does that make sense to you?
Yes. Mm.
So that's we still can use this method for the quick learner. Okay. All right. So let me see. Next, we're gonna talk about no question. I think that mostly people do not have equation for the addition and subtraction. And next, we're gonna talk about multiplying decimals. Multiplying decimals. Multiplying decimals. Let's say we want to do 1.2 times 1.3. Well, tell me, what's the first step you want to do this? What is the first step you want to do this problem?
Cross multiply, make all the numbers together.
Mhm.
I'm not gonna, do I put a decimal? Yes, you do, actually, put a decimal, because it's only 10. Yeah. Gotta go back to my childhood years, it takes me a while, a minute.
Yeah.
Put the
So you
decimal.
remember when your childhood teacher would say, "Oh,
Yeah.
just ignore the decimal point." Is that right?
Right, that's what I, yeah,
Yeah.
exactly.
Okay, and that's ignore the decimal point.
Yes,
Then we are counting back the decimal point back, right? When
Yeah,
we're doing
yeah.
the decimal point back, right? Yes.
right.
Yeah.
But it'd be more
Yeah, that's
confusing.
when you're a childhood, you're doing this, but you have no idea, right?
Mhm, right.
But today I'm gonna explain why we have to do this, okay?
Mhm,
Now you can know the decimal point. That means we take a 12 times a 13. Is that right?
exactly, yeah.
We take a 12 times a 13. So we have 12 times a 13. Ignore the decimal. That means
Mhm,
we times 10 here, we times 10 there, right?
mhm,
So that's why we have 12 times 13. Is that right?
mhm,
So you can know the decimal point. We have this 12 times 13. We take a 3 times 2 is a 6. 3 times 1 is a 3, right? Now 1 times 2 is a 1 there. 1 times 1 is right there. Correct or wrong?
No, it's not right here, you gotta move over.
You got to move over one place value, right? Yeah, that's completely wrong, right?
Yeah,
Yeah, because actually you were doing what? When teacher says 3 times 2 is a 6, correct. When teacher says 3 times 1 is a 3, so we got 36, is that right?
mhm,
But teacher say if we have 1 times 2, student will put on there.
yeah. Yeah, it's
That's
always
what
in
that's it actually is not 1. It is 10. 10 times 2. That's why we have 20 right here.
Mhm,
And 10 times 10. That's why we have 1 there. So what that'll be 100. That's why we have the move the place value right here.
mhm,
And the research says that when teacher sometimes we just skip this, just move this, without give the 0 as a placeholder. If a teacher give a placeholder like this, we're helping children understand the concept.
mhm.
Does that make sense to you in terms of
Yes.
teaching? So put on the
Yes.
0 and put on the smiling face.
Mhm,
That's how I'll do. They'll remember the placeholder,
yeah,
right?
nice. Yeah,
Instead of the 36 and 12, right?
yeah.
Right. This is a very, very common mistake that you will find in school, okay? So that's why we have to find a way to helping children with this. So add together, we have a 6, we have a 5, and 1. Is that right?
Yes.
Are we down? No, we are not down. Decimal point is right there because we ignore the decimal point, right?
Mhm. No, it's not right there. No.
Yeah. So can we line in out the decimal point? Yes or no? Can we line up decimal point right here? Yes or no?
It's supposed to
We
be
can.
one. Yeah.
We can
One
line the
half to-
decimal point.
Yeah.
Yeah. Then we have to count the decimal point back, right? because we move 1 and 2, so therefore we're gonna moving back for how many?
2.
2.
We have to moving back, right? For how many? 2, right? To the left or to the right? To the left or to the right?
Left.
You're gonna be left still.
Yeah, to the
Minus
left. For how many? 2,
2.
because we counted 1 for here and the other 2 for there. Is that right? So
Mhm.
that's why we move 2 there. So the answer is 1.56, right?
6. Mhm.
So I answer you the question. Number 1, we cannot line up the decimal point, right? Number 2, I answer you the question why we move the decimal point. Okay. Now the next, why we have to move the decimal point? Because you already ignore the decimal point. That means you times 10 there. Now you times the 10 there. So therefore totally you times 100 there. So that's why you have a whole number 12 times 13. Is that right?
Mhm.
So now we have to counting back. Now counting back, that means what? That means when we decimal point move over here, that means we divide it by 10 right here.
Mhm.
And then we divide it by 100 there.
100. Mhm. Mhm.
But let me give you another way to explain this.
Mhm.
Before children learn decimal, do they know the fraction already? Yes or no? Do they know the fraction?
I don't think so, no.
Depends on the curriculum.
Yeah. But basically the curriculum, if you look at the Common Core, children will learn fraction first, then decimal. Yeah, then decimal. So their previous knowledge will be the fraction, okay, fraction. They learn fraction first. They already know what the fraction is. Then they can convert the fraction to decimal. Then they will do the decimal, okay? So that is we are gonna connect to their previous knowledge. 1.2, can we convert to 1 and 2, 10? Is that right? So that is all connected to their previous knowledge. My previous knowledge is this, right? So look, so therefore this is a mixed number. So therefore, in 1 times 10 plus 2 is a 12 over this, times 13 over this. Is that right? Everybody doing okay here?
Yes. Yes.
Yes.
And then next, when teachers say ignore the decimal point is right there. So we have a 12 times 13, right? Ignore the decimal point, we have a 12 times 13. So what's the bottom, which is a 10 times 10, which is equal 100. Did you see this? And then therefore, we have 156 over 100. Okay, now here. Here, teachers say ignore the decimal point. So we take a 1, we take a 12 times 13. That's why we got 156, right? When teachers say, well, counting back to the decimal point, and that means we divide it by 100 there. So we divide it by 100 there. Does that make sense to you to see the picture of why we have to move the decimal point? Why we have to move the decimal point? Well, because we divide it by 100 there, right? We ignore the decimal point, but ignore, that means you times 10 right there, right? And you counting back, that means you divide it by back, make it is even, okay? Does that make sense to you?
Yes.
All right. If this doesn't make sense to you, I would like have you to try one problem, okay? Now, once you try this problem, and you want to think, why we have to move the decimal point, okay? And then here, how about doing this problem? 12 times 0.11, okay? I want you to give you a minute, do this, okay? Take a 12 times 0.11. Okay, are we done? Are we done for this problem?
Yes.
All right, good, yes. Okay, again, I'm gonna do two different way, okay? Two different method. One is a fraction method, one is just move the decimal point method, okay? Traditional way of this, 12 times 0.11 like this. So again, I wanna just ignore the decimal point, right? Now ignore the decimal point. That means here is 11, 12 times 11. Is that right? Now 12 times 11. That means 11.11. That's times 100. And then we times 100. You have to divide it by 100 back. Are you with me for this concept? That's why we say, oh, we ignore the decimal point.
Mhm.
You cannot just times without divide, and therefore it's not even.
Mhm.
And therefore we can say 12 times 11, right? Now 12 times 11, yeah, we 12 here, all right? And then 1 times 12 is 12. And don't forget about the 0 as a placeholder. Don't forget, give a smiling face.
Mhm.
You like a smiling face, right? Yes.
Mhm.
Yeah. That will helping children to say, oh, teacher, I want to have a smiling face. That as a placeholder. Otherwise, they put on 12 plus 12, okay? This is a very, very common mistake because teacher did not tell them correctly, okay? All right, so therefore we have a 2, and we have 3, and 1. Is that right?
Mhm.
Now, since you times 100 ignore the decimal point, now we're going to count it back. That means that we have to divide it by 100 here. Divide by 10 right here. Divide it by 100 there. Does it make sense to you? So the answer is a 1.332.
Mhm.
Does that make sense to you?
Yes.
So next time when you do this problem, you not just do the procedurally. You understand what's going on, why we have to move the decimal point, to level to the right, right? I think that the meaning is important. Now, what about if we look at another method? Let's say we want to do fraction. See if this is the same. We can use either fraction to explain. We can use this one to explain. So we take a 12, and then we convert this 0.11, which is 1100. Does it make sense to you?
Yes.
And then 12, actually 12 over 1 times 1100. Does that make sense to you?
Yes.
Now, When we say, oh, ignore the decimal point, I mean, we take a 12 times 11. Does that make sense to you?
Yes.
And then bottom is 100.
Mhm.
And then ignore the decimal point. That means 132 and divided by 100.
Mhm.
And therefore, we got a 1.32. And again, you want to compare here. 132 right here, ignore the decimal point, right? So that's why we whole number. And then we counting back for the decimal point. That's why we have moved the decimal point right here. Does that make sense to you? How we answer this question to children, and how we explain this? Why we have to move the decimal point?
Yeah.
Yes or no? Okay, very good. How about we take a 5-minute break? Okay. That's 5-minute break. Okay.
Mhm.
Professor, I wasn't
Yes.
aware, I wasn't aware that we had problem set 5 due. Am I still able to turn that in tomorrow?
Yeah. 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 Well, I
Okay.
think so.
I knew
Every
that we had,
time yeah, that's okay. That's okay for one-time favor. That's okay.
I knew we had 4 due last week, so I turned in 4, but I wasn't aware about today. Okay. Thank
Yeah, I
you.
think so. Everything we based on the schedule, tentative schedule. And then I will, every Friday or Thursday, I will give you a reminder for next week. What we gonna do? Yeah, you still can
Okay,
turn in,
thank
no
you.
problem. Okay, you still can turn in, no problem. Okay,
Okay.
all right. Let's take a 5-minute break. All right. Let's move on to next topic. Dividing decimals. Dividing decimals, okay? Let's say we want to do 25.5 divided by 5. Okay. So 25.5 divided by 5. So I would do this 25 divided by 5 like this. So I would take a 5 times a 5 equal 25. And decimal point right there. Then when I move on 5 underneath right here. So I take a 5 times 1, 5. So the answer is a 5.1, 5.1, okay?
Mhm.
Here, I'm gonna do another problem. This problem actually is 25.5 divided by 0.5. Oh, it's a different, right? Different from we divided by 5. Is that right? Now, what should we do? What is first step we want to do this problem? Do you still remember when you were as a childhood?
No, this one's confusing for me. I lost it.
Uh-huh. And then you, I think it's a 25.5 divided by 0.5, right? So therefore, I think it's because this is a 0.5. So we have to move the decimal point, make it as a whole number.
Mm,
And then at the same time, we can move this as a whole number, right? When you move this one, make it as a whole number, make it as a 5. At the same time, you want to do this, right? Remember that? And that means you times the 10. That's why you make it as a 5. And don't forget, you times 10 here, you got times 10 there. Make it as even,
mhm.
right? Now, what did I tell you? What did I tell you when we do the 50 items computational skill review? Do we work on here? Teach your children work on here? Yes or no?
Yes, yes. That's fine.
No. No, I didn't.
Oh.
I
Oh.
told you. I told you.
Yeah, yeah. To go at the bottom, yes, yes.
Yeah, don't work on here, please.
True, true.
Why? 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 Why we don't want to work on here? Because children were confused what the decimal point is.
Yeah.
So times 10 there, what about we just, do a nice and clean? Times 10, we got a 5.
Mhm.
Times 10 to 55.
Mm.
Remember that? When I 50 item review, I told you this before. Do not work on here because the work on here, student will do, decimal point there or decimal point there. They are confused, right?
Mhm.
Why not just start a new one? Everything is clean.
Mhm.
It not really helps them to get the right answer. Okay. So 5 times 5 got the 25 and move 25 minus 25 is 0. So move on 5 there. So that's a 51.
Mhm.
Oh, nice and clean. They always get an answer. They have not struggled anything with the decimal point. Is that right?
Yes.
Okay. So if this is okay with you, how about you wanna do this problem? Take a minute to do this one. 25.5 divided by 0.05.
Mhm.
25.5 divided by 0.05. Take a minute to do this, okay? And then I will go over this with you. 25.5 divided by 0.05. What do you think? Do you like a new method?
Yes, yeah. Listen.
All right. Let's check your answer right here, okay? Write it down.
Yes.
25.5 and then 0.05, right?
Mhm.
So move the decimal point to the left or to the right?
Right.
To the right for how many? That's 1 and 2. And then that means 5, right? And
Yeah.
therefore we have to move the decimal point for 1 and 2. Make it as even. That means we times 100 there. And at the same time, we have to times 100 there, right?
Mhm. Cool.
Do you walk on here? No.
No. Nope.
Don't do that.
Yeah.
Don't do this.
Mhm. Mhm.
Can remind you, okay? Otherwise, confused with the decimal point. How about this? Okay.
Mhm.
All right, 5.
Mhm. Mhm.
And 25, because the decimal point right there, right? Right, we move 1 and 2,
Sure.
right?
Mhm.
Yeah. So therefore, we move to the decimal point, therefore that 1 and 2. So therefore, we have 2550. Did you get this?
Yes. 25, 50.
We
Well,
studied
five.
a new, we studied that everything is new, and then we don't struggle with the decimal point where to go, right? So
Mhm.
that's a 525, and then move on 5 there, 1 and 5, and move on 0 there. So answer 510. Did you get to 510? Yes or no?
Yes. Yes.
Yeah, then you happy and then I happy because you got a correct answer. Right?
Yeah.
Yeah.
Awesome.
Yeah.
Oh,
Okay, now how about here's some problem to practice, okay? Let's do the first one, 19.6 divided by 5. 19.6 divided by 5, okay? Do this one, 19.6 divided by 5.
mhm.
All right, 19.6 divided by 5. So in this problem, we don't need any worry about move the decimal point, right? So
Mhm.
we just go ahead and do it, right?
Mhm.
And we just go ahead and do it. And then here, sometimes, the dividing decimal point is difficult to teach because sometimes I have to line out decimal points, sometimes don't, right? So in this case, we don't need to, you know, move the decimal point. We just work on here. We have a 3 times 5, which is 15. Subtract this. We got a 4. And then we have a 6, moving down 6 there. And then here, look, decimal point lining up, right?
Mhm. Yes.
Yeah. Yeah, sometimes it's lining up this kind. Here we have 5 and 9, 45, like
Mhm.
this, and the 1 and 10. Move down decimal point there, and move on the 0 there, and then so therefore we got a 2. 2 times 5 is 10. So the answer is 3.92. Did you get this right?
Yes.
How about doing this problem, okay? Try the second problem. 19.6 divided by 0.6. 19.6 divided by 0.5. 19.6 divided by 0.5. All right. All right, good. So I move the decimal point, right there. And at the same time, I need to move the decimal point right there. So therefore, I have a 196 divided by 5. Started a new scratch, okay? So we have 5 times 3, which is 15. Subtract this, we got a 4 remainder, and then 6 there. Move there, 6 there. So we have a 9 times 5, 45. And then 46 minus 45, that go 1 there. And next, decimal point, don't forget about decimal point right there, right? So move on the 0 down there, so 2. So did you get the answer? 39.2, yes or no?
Yes.
Very good. How about the last problem for today? Okay, 19.6 divided by 0.05. Take a minute to do this, okay? Last problem for the day. All right. Okay, check your answer right here. So I have to move the decimal point 1 and 2, which is I times 100 there. And then same time we have to times 100 there, right? Make it as even, right? So therefore I have 5 here. And then I have 1960 for this. Start a new one, okay? And we have 3, 15, 3 times 5, 15. And then move on 646, which is take a 9 times 5, 45. Subtract this, I got a 1, move on 0 there. Oh, so the answer is a 392, right?
Yes.
All right. Okay, this will be the last problem for the day, okay? Do you have any questions? All right, so if you have any question, you can stay here to help. I'd be happy to tutor to stay here, ask me. If not, we are here for today. Thank you. Yeah, and next time, I think so probably you know how to get in, right? Yeah, probably you have to log in through like, the link I sent to you, or maybe from the Teams calendar.
Yeah, I logged in through the email that she sent originally, and so was everybody else. They were there, but I don't know what happened. But so we missed like a half hour. You're gonna send the recording? hopefully.
Yeah, I send a recording to you. Okay. Yeah,
Okay.
after every class, I will send a recording to
Yeah.
to the class. Okay. Make sure
Yeah,
you don't
inshallah.
miss anything. Yeah.
Thank you.
Yeah. Sorry about that. The technology, I don't know.
That's
I
fine.
just
It
I
happens.
don't
too.
know.
It's
Just
just-
technology. I don't know.
Yeah,
All
that's
right.
okay.
So
But
we are
next
here
week
for
we
today,
know.
everybody. Okay. Thank you.
Thank you so much. Take care, Professor.
Mhm,
Bye,
mhm.
guys. Have a good night, everyone.
Bye.